Hi, my name is Matthew Mullis, and this is my Physics 2212 Lab Report 2 on lines of charge. So, the purpose of this lab experiment was to show the interaction between two electrically charged pieces of tapes in a computational model, also known as U-tapes. The data from this was used to calculate the amount of charge that is necessary for one piece of tape to hover in the air due to the other because of the electric force being applied. In Lab 1, each tape was considered to be a single point charge, but this lab viewed each of them as being the charges being evenly distributed on the piece of tape. In Lab 1, we found the tapes to have a charge of 1.8 times 10 to the negative 7th coulombs, but in this lab, we found a magnitude of electric force of 0.0399126 newtons, a magnitude of gravitational force to be 3.5316 times 10 to the negative 3rd newtons, and a charge of 5.896 times 10 to the negative 8th coulombs. So some key principles that we'll use is Newton's second law, which states that the net force equals mass times accelerations. Newton's third law, which states that for every action there is an equal and opposite reaction, as shown in the forces of the two pieces of tape. The electric force, shown or Coulomb's law, which is the electric force equals 1 over 4 pi epsilon naught times charge 1 q1 and charge 2 q2 over the magnitude of r squared times r hat vector, and Coulomb's constant of k equaling 1 over 4 pi epsilon naught, which is equal to 8.98 times 10 to the ninth newtons times meter per squared over Coulomb squared, and as well as superposition, which we used for calculating the charges of E net for the x or y being equal to the sum of E1, E2, E3, and so on and so forth. Some assumptions we made were to ignore the air resistance of the environment, that each piece of U-tape has equal charge, and we assume that even distribution of charge across each piece of U-tape. Our system in this experiment were the two pieces of tapes, and the surrounding was everything else, such as, my hand that was holding it, the earth, gravity, all that good stuff. So here's our code, the code that I used. We've starting at the top left, we have some constants and then the values we found from lab 1. Then we defined our electric field, we defined our line charge, as well as our top and bottom piece of tape. Then continuing this, we set our scales for the electric field vector arrows, as well as the electric and gravity force arrows. We set the scale for those. And then finally, we found the different values of the electric forces and gravitational forces through these computer calculations. So our results, the tape, like we said in the beginning, had a magnitude of electric force being 0.0399126 newtons, a magnitude of gravitational force of 3.316 times 10 to the negative third newtons, and a charge of 5.89646,583 times 10 to the negative eighth coulombs. And here's an image of what this looked like, shown by our computer model when it ran it through. So the discussion, our what if question. What if we had modeled each of our tapes as a single point charge, like in the previous lab, and we would have received an equal charge as we did in the last time? So, which was, I believe, yes, that charge was actually bigger. And then why these estimates differ so much? There's over a factor of 10 times difference. And this is because the first lab was very oversimplified, taking that large piece, or not large, but a good sized piece of tape, and assuming it to be a point charge is not accurate. So this lab is a lot more likely to be accurate. Thank you for watching and have a great day.